One of the last things we have to talk about in acid-base equilibrium is titrations. Yes, we cannot skip titrations. So there are different kinds of titrations. You can have strong acid, strong base. You can have weak acid, strong base, or strong acid, weak base. And this one on this Pencast, there is only the strong acid, strong base, and then weak acid and strong base titration. So there are two problems we're going to work on. The first one, what is the pH of a solution that is 25 milliliters, 0.220 molar NaOH after 8.10 milliliters of 0.252 molar HCl has been added to this. Okay, so which means that we have sodium hydroxide plus hydrochloric acid to give us sodium chloride and water. And the important thing is that the mole ratio is 1:1. If it wasn't, we would be calculating the mole ratios also. Okay, because then you would need 2 moles of the hydroxides or whatever it is. Okay, all right then. So 25 milliliters of 0.220 mole times 25 milliliters gives us 5.50 millimole. Hydrochloric acid 8.10. Let me write this in different ways. 0.252 molarity times 8.10 milliliters. Okay, and this gives us 2.04 millimole. Okay, so that is how much of the acid has been added. So sodium hydroxide is still the higher concentration, okay, because you have more moles of this. So then you subtract the 2, so which means 5.50 minus 2.04, 3.46 millimoles of sodium hydroxide. Okay, that is left. But the key thing here, don't forget, is the total volume, because the volume has changed. Okay, it's not the same anymore. You have 25 plus 8.10, which is 33.10 milliliters. All right, and so then you go ahead and calculate the molarity of the hydroxide ion concentration, because that's what you have here. Sodium hydroxide is in excess. So 3.46 millimole divided by 33.10 milliliter is equal to 0.105 molarity. All right, so milli is going to cancel out, so that's moles over liter. So then the POH, of course, is going to be the negative log of 0.105. This is 0.981. Question is asking for the pH, so pH is equal to 14 minus 0.981, and that is 13.02. Really high pH, which is what it should be because it's a strong base. So for pH of solutions with strong acid, strong base titrations, you need to subtract the smaller number of moles and then make sure that you add the volumes up. Okay, the total volumes, don't forget that, to find the new concentration. That is the important part. Let's try another one over here. Now this one is slightly different because this is going to be a weak acid, strong base titration. So calculate the pH when 20 milliliters of 0.5 molar acetic acid is titrated with 7.45 milliliters of 0.5 molar sodium hydroxide. So sodium hydroxide is the strong base here, all right, and then of course the Ka is given to us. And so let's go ahead and write our equation out, which is CH3COOH plus NaOH. That's the titration that's going on, and then CH3COO minus plus water. Okay, those two are products. So our initial concentrations then, okay, are what is given to us already, which is 0.5 times 20 milliliters, and this is moles per liter, and then sodium hydroxide is 0.5 times 7.45 milliliters. Okay, and this is going to be 10.00 millimole, and this is going to be 3.73 millimole. Okay, when you do the calculation, initially there is no products. Okay, and of course we don't care about water, so the acetate ion is 0. So the change then, okay, the change is going to be, again, you have to subtract the smaller amount, okay, that we have in there. So the change then is the minus 3.73 over here, minus 3.73, but then you have to add 3.73 moles, millimoles on this side, okay. And so then at equilibrium, you have 10 minus 3.73 0 over here, and then 3.73 millimoles over here. So this, when you do the subtraction, this is 6.27 millimoles. All right, so those are our concentrations then, and then we go ahead and plug it into our equation that we know about, and we have started loving it. H3O plus is equal to Ka times the acid concentration over the base concentration. So this is 1.8 times 10 to the negative 5 times, and again you can take the moles over here, okay, because the volume is the same. So if you were to divide with the same volume, it doesn't matter anymore, okay. So I mean, you're going to get the same, it's the same thing, it's the ratios. All right, so don't have to worry about dividing by the volume. In the strong acid base, you have to remember it because there is no ratio thing that you're doing. But here, since it's a ratio, you can skip that. 3.73 is our base millimoles, and so then the hydronium ion concentration is 3.03 times 10 to the negative 5 molar, and so therefore the pH is going to be 4.52. Okay, that's the negative log of 3.03 times 10 to the negative 5. So that's how you would do for titrations of weak acid and a strong base.